Alright, ladies and gentlemen, here's the same picture as the last video. Wonderful. In this video, the second part of Chapter 10, Section 7, the essential question is still the same. How do you find the points of intersection of a circle and a line? But this video, we're doing it algebraically as opposed to the last video that was graphically. So, just to recap, here was the example that we did in the other video, but this was the graphical way to do it. So the question is, find the points of intersection of the two graphs of x squared plus y squared equals 13 and y equals x plus 1, this linear equation right here. And remember, graphically, here's what we did. On the coordinate plane, we actually found this 13 not to be the radius, because that's the standard form of the equation. Standard form of the equation of a circle, centered at the origin. We took this 13 right there and we square rooted it, which gave us, if you remember, a good old, here, let me grab this. We square rooted this thing right here, which gave us a radius of somewhere around 3.6. So when we graph that 3.6, right there, 3.6, right there, negative 3.6, right there, negative 3.6. And when we graph that thing, beep, it looked like that. Wonderful. And then remember, we come over here and graph this linear equation on the same exact coordinate plane. We kind of transposed it right on top of the circle. We use the y-intercept of +1, and we use the slope of +1, which is right there in front of the x. And then we graph that line. So we started at 1, up 1 over 1. Wait, we started at 1, up 1 over 1, line, or dot. Up 1 over 1, dot. Up 1 over 1, dot. Up 1 over 1, so on and so forth, which created, which created this line, boo, right there. And then our answer was, remember, the points of intersection. So that dot right there, that coordinate plane, that ordered pair, 2, 3, and this ordered pair, -3 and -2, were the two answers of the points of intersection. All well and all wonderfully, wonderfully great. But the question here, and how I'm going to show you, or what I'm going to show you in this video, is not graphically, that way. We've got that one mastered. We're going to do it algebraically. So, hold on to your seatbelts, boys and girls. Here we go. Same example needs to go into your notes as it was before. Write it down again. I'll give you a couple ideas of what we're going to do, but we're doing this again, as you see over here, graphically. So here's your equation of the circle, and we're not graphing it on this one. I'm showing you algebraically how to do it. And over here is the linear equation. So here's the scoop. What you're going to do is use something called substitution, which we talked about when we solved systems of linear equations, where we had two equations and we took one and substituted it into the other one. It's exactly what we're going to do here. We're going to actually take this thing over here and substitute it into the circle equation. Now, if I was you, what I'd write down is this. I'll say it slow so you can catch it, but you can pause the video anyways. The very first thing you have to do is focus on the linear equation, and you must solve that thing, solve the linear equation for one of the variables. So whether you solve it for x or you solve it for y, it doesn't matter, but you got to solve it for one of the variables. In this case, you're lucky, it's already solved for y. But you might have to do a little work otherwise, or in other examples. This one's a little easier because y is already by itself. So it's solved for y. Well, what am I going to do then? What I'm going to actually do is this. I'm going to take this thing right here, the x plus 1, since that is equal to y. So all of y is equal to that thing in the box. Well, I'm going to take that whole thing that's in the box, and I'm going to substitute it into the circle equation where the y is, right there. Everything else is going to stay the same. The x squared is going to stay exactly the same. Lovely. The plus is going to stay the same. The actual squared right here on the 2 is going to stay the same. The equals is going to stay the same. And the 13 is going to stay the same. Nothing else changes except, ladies and gentlemen, this goofy little y. I'm going to take, again, this whole thing, x plus 1, I'm going to put it in for y. But I hope you see how I'm doing it. You better do it the same way. Put parentheses around it, because that is extremely important. Because now what I have, once I took this x plus y and substituted it in there, I have an equation that I must solve for x. Oh yeah. And by the way, before we go further, remember, this is the same example up here that we just did earlier, and these right here were your two answers over to the right. So we got the points of intersection to be 2, 3, and -3, -2. So I'm going to show you here throughout this algebraic example of how we get these same answers over here. Okay? Back to this. Well, what do I do? Well, let's see if I can change colors. I think I can. I'm pretty good at this now. So let's make it blue. I have to take this thing right there. Oh boy. It's a binomial that I'm squaring. No. Don't you dare distribute the 2 through there. You have to take that binomial, that's right, and you have to double distribute, aka you must FOIL. Okay, so I'm going to pause the video right now, and I'm going to kind of work ahead here, but you can solve that bad boy real quick. Pause the video, and then you can start the video and see what it actually comes out to be whenever you FOIL this out. So there it is. It's x squared plus 1x plus 1x plus 1 when I do first, outers, inners, last. I just got to clean this up. So it's really x squared plus 2x plus 1. So that is, keep in mind, that's this whole thing right up here that I just took and I FOILed it down to this. Now, I have to bring down everything else. I still have the x squared. It's still a part of this question. I still have the plus up here. That's part of the question. I still have the equals 13. So all of this is equal to 13. Oh, lovely. Okay, let's keep going. So, now I must take this equation and keep on solving it. So let's combine it like terms. That gives me 2x squared. Lovely. 2x, there's nothing else like it, so it just stays plus 2x. That's cool. But I can do this. I have 1 and I have 13. So let's get rid of this 13 from the right side by subtracting it on both sides. What's that give me? It gives me minus 12 over here on the left. So now I have this goofy quadratic equation, 2x squared plus 2x minus 12. Awesome. What's next? Well, we got to factor this thing. We're solving it for x. So let's first of all look for a GCF. Is there one? You bet your bottom dollar. There is. There's a 2. So if I take the 2 out of there, so x squared is what it remains, plus take a 2 out of that one, gives me x. Take a 2 out of this one, gives me 6. So there we go. So I'm going to take this trinomial now, and I'm going to factor that bad boy into 2 factors. One looks like that, and one looks like that. How do I do it? Well, we must do the x box. So pause it, do the x box, and put your factors in here and see if yours is the same as mine. Don't forget the GCF, bring that down. Don't forget the equals 0. So pause it and see what you get. Oh, did you get the same thing? X box here, I took the actual 6, or negative 6, sorry, I put that up there. I put the 1 right there. So I was looking for 2 factors that multiplied to give me negative 6, but they needed to add together to give me 1. Bam. And notice this. This 3 and this 2 just translated right over here. Why? Remember, it's because I have no coefficient other than 1. Let's be honest, that's a 1 right there. There is a coefficient there, just a 1, where it's x squared. So it just translates over, bam, just like that. When in doubt, of course, FOIL it back out to make sure it goes back to x squared plus x minus 6. So we got all that. Wonderful. Now you may ask, what do we do to finish this question? Well, I am still looking for my ever elusive 2 points over here. And I'm almost there, but I'm not done yet. So now I must use the old ZPP, yeah, you know me, to solve this thing finally for x. So I have 2, that's one of my factors, equals 0, but that's a non-issue because that doesn't even make sense, so let's just rule that out. But I have x plus 3 down here, that's another factor, x plus 3, that equals 0. So there's one of those, using ZPP, the zero product property. And the other factor, I'll use x minus 2, which is down there. I set that equal to 0 as such. So here's my possibilities. Either x plus 3 is equal to 0, or x minus 2 is equal to 0. Solve this by subtracting 3 from both sides, 3 from both sides. So there's one of my possible x's. Time out. Check this out. Oh, that actually rhymed. Time out. Check this out. Well, it didn't rhyme. It's the same word. Anyways, x equals negative 3. Look. There's your x. There's one of the x values of the points that we found. Yeah. Over here, if I solve this one, I'd add 2 to both sides. Add 2 to both sides, which means I get x equals a positive 2. That's right. X equals positive 2. Check this out. That's the other x coordinate of the points. Now, here's how you'd be looking at this. Whew. So you'd have x equals -3. That would be one of your ordered pairs. And you'd have x equals 2. That would be the other x value of your ordered pair. We already know the answers up here from the graphic example we did. But now remember, I'm showing you this algebraically how it works out, so we'd have to assume we didn't know those if I just flat out gave you this question. So how am I going to solve and how am I going to find the y value? Well, this is the x. I need the y. This is where you need to write something down as well. Star it, circle it, highlight it, whatever. Here's what I would write. Plug the x value back into the linear equation for x. Right there. Hope you didn't miss that. You take the x value, whether it be the -3 or the 2, and you plug that back into the linear equation. And then you simply solve it for y. So, let me erase some of this stuff. We'll clean all this stuff up over here, and then we'll finish this out. So, I'm taking this -3 and I'm plugging it right in there, so I have y equals -3 plus 1. So if I do that simple math, it just means I have y equals a -2. So there is one of my ordered pairs. I have the x of -3, and I have the y of -2. Check this out over here to the right. Bam! That's that one right there. Oh yeah. And if I do the other one, if I take this the +2 that I got from all the work that I did earlier, ZPP and all that, I take the 2 and I plug it back up in here, and I put a 2 in the x. So I take this 2 again and I plug it right there. This is like a big old football play. All these things going here. You go over there, you go there, go down the sidelines, touchdown. So I'm taking that 2 and putting it in for x, which means I put it right here. So that just gives me y equals 2 plus 1, which is 3. So there's my other ordered pair. The x again is 2, and the y is 3. And there is the same exact answer. Here comes another person from the football play. Just kidding. So there's your 2 answers. So that is cool. So wow, go back and watch this video. But what we did is originally, if you remember, we took this goofy thing right here. We took this whole thing, that whole thing that's highlighted, and we substituted that in to the y right there. And then we did everything. We foiled it, if you remember. These are kind of the steps. We foiled it. After we foiled it, we kind of cleaned it up a little bit. And then we Xboxed that bad boy. And then after we Xboxed that bad boy, then we did the old ZPP. Now you know me. Did that. And then after we did ZPP, then we took the x's, whatever we got, those 2 x's, and we substituted them back in right there. So we took that x and we substituted it back in right there. And we solved it for y. Awesome. That is a great, great, great question. Long question in terms of the work, but you guys are going to be able to master it because it pulls together a lot of stuff we've already done. So I'm excited to practice these in class. We'll see you there. Peace out. Later.